So what about make dir and remove dir? Make dir creates a new directory. We've done that a couple times already, but we can create a new directory. Let's call it YY. Why, I don't know, but we'll call it YY. And we can put some file into that directory. Like we can take ls and we can send the output to yy.bob.txt. When we want to remove a directory, we use rmdir. You can't just remove a directory, you have to use a special command. It helps prevent people from accidentally removing directories. But let's say we want to get rid of YY, and you'll notice that it says the directory is not empty. rmdir will only delete a directory if the directory is already empty, and if we list YY, we've got this file in it. Now I can use a relative path and delete that file with remove. I can remove YY/Bob, and now if I do rmdir, the directory goes away. By and large, success for most files, most Unix command line things, doesn't print out any nice message, and there's no little prompts about, are you certain you want to do this? By golly, if you type it in, you did it. And unlike the GUI tools where deleting isn't really deleting and you've got a waste bin and you can recover stuff, in the land of the GUI, you lived a dangerous life. Or in the land of the command line, you're living a dangerous life. If you remove stuff, it's gone. And there are some things that you should be inordinately cautious with. There are options on remove that allow you to remove entire directory trees recursively. There is a rm-rf, and I could say rm-rf, and this will remove this directory and all of its contents recursively for however long you want to go. And it will remove entire directory trees. So this is sufficiently dangerous that some systems will actually limit your use of this, because by golly, remove forced recursive is just right up there, and you can destroy entire computer systems in the click of a button. Just like that. So that's how you create and remove directories. You'll notice that the directory my is now gone, although it did have files in it. It has just disappeared, never to be seen again. Now, we've used this cat program. It stands for concatenate. And you'd go, but cat doesn't concatenate anything. If I do a.text, it shows it on the screen. If I do a.text, b.text, there it is on the screen again. In fact, I can do cat star.text, and I can get both of them. We'll get back to what the star does there in that context. That's actually built into the shell, not built into cat, the star. So yeah, you can do that. But there is one of the major inventions of the land of Unix, and that is pipes. And I've used some already, but let's get really specific. If I want to put these things together, I can do cat a.text, b.text, and you see what the output is from doing cat on both of those. And I can send the output to all.text. And now I can do cat all.text, and you'll see that it has those two things concatenated. So this single character allows me to take the output of one command and stick it in a file. Now, if I want to find the threes in there, we've used grep before. We will spend some time working with what grep will do. But I can say grep for 3.3 in all.text, and I can find the lines that have 3.3 in it. But I've actually created a file that has all of this stuff in it. So let's say that what we really want in our file is 2 copies of b. We can say cat a.text, b.text, b.text. And we can create a new file that has 3 copies of the b file in it. So we can use it to concatenate files, and that's why it's called cat. But suddenly you notice I'm using this pipe, okay, That's this little guy right here, to say, yeah, I want to take the output of one thing and send it to a file. We can also use this to combine or to send input to files. Now, if I just type cat, you'll notice nothing seems to happen, but in fact, I'm taking the input from what I'm typing and it's producing the output. And on a Unix system, Control D is end of file. On Windows, Control Z is end of file to get out of that. But yeah, this is taking stuff and echoing it back. So it'll read the input. And we can do cat -n and add line numbers. Now, maybe what we want to do is we want to have line numbers for these files. So if I do cat -n a.text b.text, we get line numbers, but it's per file. You notice it goes down here to line 6, and then it goes 1, 2, 3, 1, 2, 3, 1, 2, 3. And we really want it to be continuously numbered. We can do, instead of this, we can say cat those files, and then there's another pipe symbol where we're going to send it to a different process. And now we can get continuous line numbers for all of it all at once. So the vertical bar allows me to take the output of the first command, cat, and send it to the input of the next command, which happens to also be cat, and provide different options. We could use our pattern matcher, grep, to say I want to find all the lines that have B, but I don't have line numbers. So I can go back here to the one that has line numbers, and I can say grep B, and I can find out that in the output of these three concatenated things on line 8, 11, and 14, I have a B. And that's not the most exciting thing, but inside your code, this can suddenly be really useful, where you can add line numbers, you can look at where things are, you can go looking for patterns in things. So this gives us the ability to combine programs together. We can also say cat with the input. Remember, we created all.txt a little bit ago. Take the output of that to grep3. And I can find that in all.txt that I've sent in to cat, that I've piped it to grep, and I found all the 3s in that fashion. Lots of these things aren't so useful in and of themselves. There's a command yes. Let's just do the man page. By golly, let's read this. Be repetitive affirmative. Oh boy, this is really a dull command. It says it outputs repetitive, or which is the option on the command line, or by default, Y forever. You go, okay, this is useless. But if you have some other command that needs a bunch of yes prompts, you can take yes and pipe it to that command and give it all yeses. And it'll run until that other command quits absorbing input. So there are uses for these things that are quite odd. Okay? If you do man touch, touch is another command. Oh, and it's got a much longer description. Change the file access and modified times on touch. We'll get to why touch is useful, but it allows you to change when this date information it actually applies. So that I've got this thing that was done April 16th. Okay, up here. This really weird file name. I can say touch. I happen to know it's a blank. And now it says April 17th for when the date is. And that didn't edit the file, it just changed the timestamp on the file. I touched it. Now, in and of itself, touch isn't very useful, but if your backups are done incrementally over time, and for some reason you want to force the backup to say, yeah, incrementally over time, I need this file to be included in this backup, you might want to touch it. So, it's an odd little command, but it has some uses. The big use is with something else called make. We'll get back to make in a little bit. But that's kind of the thing with pipes. There are three of them. There is the interprocess pipe, there is the output pipe, and the input pipe. There are some others. There is an inline pipe and a few things like that, but those are the big three ones. So you can take any command and you can get the output that comes on the screen to go to a file. And we've looked at a pattern matcher. We can duplicate stuff. We can concatenate stuff. The thing that I have left out here is wildcards. If I do star.text, I see that I've got some stuff there. But what's really happening is the shell itself is expanding the wildcards. So if I do echo star.text, you'll see that what did it have when it passed stuff to it? It had all those files passed to ls. And it said for the ls command, I want you to list that set of things. Most Unix commands will take more than one file on the command line and allow you to work on sets of files. So they're not onesie, twosie things. They're for this entire set, do this. So I could say grep3 for star.text and find all the places that the threes appear in all those different files we created. And when you have grep and you have more than one file, it also lists which file name it's in. You can get, there are a slew of options on grep. So far, what have we got in terms of command? We've got concat that concatenates commands, move that renames stuff, ls lists a directory and has a bunch of options that we can use, remove gets rid of files, makedir and rmdir create and destroy directories. pwd tells you which directory you're currently in, so you can know what your relative paths will do. We've talked about absolute paths. cd allows you to change into and out of directories. That actually changes what your current directory is. Man, remember it's a Q to exit it at the bottom or a space to go to the next screenful. Man lists manual pages, or you can Google for a manual page for things. If you put man in some command like grep, it'll give you the manual page for that. Grep, which is pattern matcher. We're going to spend some more time with grep. PS, which I just barely touched on, lists processes, and kill can be used to terminate a process. Awk, a programming language. Cut, which we haven't looked at yet, but allows you to cut out columns of things. We're going to get back to it. chmod, which we've looked at quite a bit, which changes permissions. And inside scripts, there's #bang, which tells it what kind of a script you're trying to build. Pretty much any tool that you can run a program in, you can build a script for, and you can get the shell to run it as that kind of a script. So the one we've seen is bash, the shell itself, for running scripts. But awk is a programming language, and I can put awk up there at the top, or another programming language is Perl, we can do Perl. So there are all these different kinds of programming languages that can be used as scripts. And they have different utilities and different capabilities. But that's kind of the set of commands that we've touched on so far. There's still a couple in there we're going to come back to. But basically, this is going to allow you to take these things and stitch them together with pipes and start building more complex things. This is the assembly language of the command line. And we've also touched on the fact that this is an extensible set. We can create our own commands that fit in and process this stuff as well. So these are kind of the pieces, okay? We're going to start looking at combining these pieces into bigger and more useful things. But you can start wrangling the command line and using it to your advantage. And unlike a GUI, it has the advantage that these things are compostable together. And you can build bigger and better things out of them easily. So that's kind of a touch on the command line. We're going to get back to that in a little bit and see how we can use it more effectively.